Hello friends, welcome. In this video we will see the SN1 reaction mechanism. In the previous video we have seen SN2 reaction mechanism. This mechanism we will see with the help of examples of tertiary butyl bromide and hydroxide ion concentration. So hydrolysis of tertiary butyl bromide means this is a tertiary butyl bromide and this hydroxide ion concentration is in aqueous. Will get tertiary butyl alcohol and this Br minus I. See, this reaction follows the first order kinetics. This is the first order kinetics. See, why this sentence is written? Because the rate of reaction of any reaction is studied with the help of kinetics experiment. So the kinetic experiment indicate that this reaction is a first order kinetics. That means the rate of this reactions depend upon one of the substrate, that is tertiary butyl bromide. You can write this as a rate is equals to K molar concentration of this tertiary butyl bromide. This equation, rate law equation, is a rate law equation. This rate law equation indicates that the rate of this reaction is only depend upon the tertiary butyl bromide and is not depend upon the OH minus ion concentration. As well as here only one of the substrate is present in the rate determining state. Only one of the substrate. That's why this reaction is called unimolecular reactions. Here this Br is replaced by the another nucleophile. The Br is also nucleophile. This is a good leaving groups and this is good attacking groups. So the Br is replaced by the OH. So this is called substitution reaction. So S stands for substitution. And N, this one nucleophile is displaced by another nucleophile. That's called nucleophilic. This nucleophilic substitution unimolecular. That means this one is unimolecular and is nucleophilic and the S is substitution reaction. So this rate law equation which is depend upon the rate determining step. So you should know first what is meant by rate determining step, and we'll see the rate determining step. We'll first understand what is meant by rate determining step. So rate determining step, this we can say consider one example, and with the help of examples we can see what is meant by rate determining step. So suppose A is converted into P is the example in which suppose number of steps are involved. So A is converted into B, B is converted into C, C is converted into D, and finally suppose D is converted into P. That means A is converted into P. In between the number of steps are involved. Suppose this first step is the fastest step. The rate of this reaction is fast. This is the suppose slow reaction. This is suppose fast reaction. This is suppose slowest reaction. Then see this, each of this reaction is a simple reaction or this is a single reaction, single step reactions, and the rate of this reaction is depend upon that reaction which take place at the slowest speed. See, this is the slowest step reaction and the rate of this overall reaction is depend upon the slowest reaction. जब तक ये रिएक्शन फिनिश नहीं होगा तब तक पूरी रिएक्शंस स्टॉप नहीं होगी. Once the reaction is this reaction is stopped, then practically all reaction will be finished. All reaction will be stopped. That's why जब तक ये रिएक्शन नहीं फिनिश होगा तब तक रिएक्शंस स्टॉप नहीं होगा. So इसका रेट सबसे कम है. That means this reaction which determine rate of overall reaction. Therefore the kinetic equation is written based upon this, that is the rate of this overall reaction is depend upon this substrate which is present in the slowest step of the reaction. So this is the slowest step, and in this slowest step this D is the substrate. So rate of this reaction is depend upon D, concentration of D. Same case, in this reaction the rate is depend upon the concentration of the tertiary butyl bromide and is not depend upon the hydroxide ion. So this is involved in the rate determining step. That means this reaction takes place in two steps. In the slow step, means rate determining step is the slow step, which determines the rate of the whole reaction. That means another reaction must be present, that is a fast reaction. So these reactions involve two steps. We will see these two steps, that is the SN1 reaction mechanism. So step 1 in this SN1 mechanism, step 1, this is the tertiary butyl bromide is a substrate and is a reversible reaction. This is the rate determining step, is a slow step in which this carbon and bromine bond will be heterolytically break, or this is called the heterolysis of CBr bond. So both electrons will draw towards the bromine because of its more electronegativity. So bromine carry negative charge because one electron of this carbon comes to the bromine. So the bromine carry here negative charge, and this carbon which carry here, this carbon carry positive charge. So this is called carbocation, and the geometry of this carbocation is planar. It's a planar geometry, and this is also considered as an intermediate. This is intermediate in this reaction. Now step second, this carbocation which is attacked by the nucleophile OH minus, in which this electron pair is used in between this carbon and oxygen of this OH. So this lone pair electron which is used between by this carbon which undergoes change, and we will get tertiary butyl alcohol. It's a fast step reaction. See, this reaction has some silent features. So we'll see silent features of these reactions. Silent features of SN1 reaction. See, we'll see the first point about the silent features of these reactions. The first point is that this reaction takes place in a two step. The first step and this is second step. The first step reactions. These are first silent features. Second silent features, in the first step, the heterolysis of the CBr bond will be take place, which is a slow step and reversible, in which the planar carbocation is formed, is acting as an intermediate. Next, third point, the second step is a fast step in which this nucleophilic attack takes place on this carbocation carbon to form the tertiary butyl alcohol, which is a fast step reaction. Next, fourth point of the silent features, if this substrate is a optically active, that means when the chiral carbon in an optically active substrate is present, then the product form becomes racemic. That means the SN1 reactions which proceeds with formation of the racemic mixture, or the SN1 reaction is proceed with racemization. Racemization, that means the both enantiomers of the product form becomes almost equal. What I say? The enantiomers, both enantiomers of the product becomes almost equal. So the SN1 reactions is the result of formation of the carbocation. Why? Because the carbocation is formed, then the attack of the nucleophile OH maybe take place either from the back side or from the front side. Is back side attack or front side attack. Then the product form become almost equal. That is the enantiomers, two enantiomers will be formed. One is the R, another one is the S. So the SN1 reaction is the result of formation of the carbocation. Carbocation when obtained, then the OH may be take place, attack of the OH take place, or nucleophilic attack may be take place either from the back side or from the front side. Then the both the product of the enantiomers becomes 50%, 50% S and 50% R. Many of the students they are not aware about the enantiomers. So enantiomer मतलब क्या है? Suppose the substrate is optically active. Suppose the substrate is optically active. That means suppose here different A, B, C and D. These are the different groups or atoms attached to the chiral carbon. Then the mirror image of this is a mirror image. That is A, D, C, B. So these two are the molecules in which the central carbon is chiral, is attached by different atoms or group of atoms, and the mirror image of the one is the, see, this is the mirror images of each other, and so these two are not placed one over the another exactly. So this is called as the enantiomers, and such kind of the two enantiomers is obtained in these reactions with equal amount. That means if the S and R, S configuration and R configuration, this is become 50-50%. So the product form becomes a racemic mixture. Racemic mixture, and this racemic mixture is optically inactive. So in the SN1 reaction, SN1 reaction is the result of formation of the carbocation, just now we have seen, and the carbocations on which the nucleophilic attack may be take place either from back side or from front side. That's why we get two kinds of the product, that is the R configuration and S configuration. So R configuration is a 50% and S configuration is also 50%. So such kind of the two product is obtained, and this mixture is called racemic mixture, which is optically inactive mixtures. So we'll see the last point of the solid features, that is the potential energy diagrams. So potential energy diagrams, we'll let potential energy on this side and reaction coordinate. Suppose this is the potential energy of the reactant. See, the reaction takes place in two steps. Just now we have seen in the first step. will get the carbocation, and in the second step we have seen the carbocation is converted into the product. So this is a substrate, so potential energy of the substrate is this, and is converted into the first transition state and then the intermediate, and intermediate is then again converted into the product. So this is the first transition state, this is the second transition state, this is the carbocation, this is the product, this is the reactant. So this is the potential energy of the reactant, this is the potential energy of the first transition state, this is the potential energy of the second transition state, and this is the potential energy of the intermediate, this is the potential energy of the product. So potential energy of the first transition state and reactant, and this difference is called delta E1. The potential energy of this carbocation and this second transition state is called delta E2, and the potential energy of this product and reactant, and this is called delta H, is the heat of reaction, heat of the reaction. So this heat of the reaction is negative because here the product, potential energy of the product minus potential energy of the reactant, it comes negative quantity. So this is the explanation about the SN1 reaction. See, in this reaction this delta E1 is greater than delta E2, this is smaller and this is a bigger quantity. Okay, thank you for watching this video, and you can share this video with your friends also. Thank you very much.